Schrodinger wave equations. The wave particle nature is a mathematical equations known as Schrodinger wave equation. The Schrodinger wave equation, there are two types: time dependent wave equation and is a time independent wave equation. So first of all, we find what is the wave time dependence equations. First case. Okay, so the particle potential energy V, kinetic energy 1 by 2 mv square. So total energy's value V plus 1 by 2 mv square. Understand? The potential energy, kinetic energy, that is value for total energy's values. So now 1 by 2 m square v square divided by m, because multiply and divide by m, there is no change of values. So now m square v square. So mv is equal to momentum. That value is equal to p. So p square. So v plus 1 by 2 p square divided by m. Okay. So that is value for e values. Now apply wave function. The wave function simple is psi. Both sides multiply. So e of psi equal to v psi plus 1 by 2 p square of psi divided by m. Okay. Now this equation number 1. Okay. So now we go to the classical theory. That means according to classical theory, the particle positions is x, velocity v, and any one timing period t values. But the equation is y is equal to e power minus I omega t minus x by v. Okay, just apply for wave functions. So psi equal to x, y is a 3 dimensions, and any one timing period t is equal to e power I omega t minus x by v. Okay, just apply for wave functions. So omega is equal to 2 pi mu, because omega is the angular frequencies, is equal to 2 pi mu for frequencies value. So just apply for omega is equal to 2 pi mu values. So x, y, z and t equal to e power minus I 2 pi mu into t minus x by v. Okay, just multiply inside mu. So e power minus I 2 pi mu t minus mu x divided by v. Okay, so here just apply E is equal to h mu's value. Already know that energy's formula. E is equal to h mu's value, and mu is equal to E by h. Mu is equal to E by h value, and mu by v is equal to 1 by lambda. U by v is equal to 1 by lambda. So just apply that is value for 1 by lambda, v by h values. X, y, z and t equal to e power minus I 2 pi into e by h into t minus x by lambda. Okay, here lambda is a de Broglie wavelength. It's a particle nature wavelength. That's wavelength formula is h by p. Okay, Planck constant divided by momentum values. So just apply h by p value. So p automatically goes to numerators, then divide by h. So x, y, z and t equal to e power minus I h e by h into t minus px divided by h. So okay, here 1 by h, 1 by is a common factor. So common factors go to e power minus I 2 pi by h into et minus px. So okay, here h cross value is equal to, that value is equal to h by 2 pi. Okay, just assume h cross is equal to h by 2 pi's value. here the form is 2 pi by h, so that is valid for 1 by h cross value. So just apply h cross is equal to h by 2 pi's value. So e power minus I by h cross into et minus px. Okay. Now this equation number 2. Okay. Now differentiating equation 2 with respect to x. Okay, equation number 2 differentiating with respect to t value. So here it's value for dou psi by dou t. So dou psi by dou x is equal to what is that? E power minus I by h cross into et minus px. Okay, like is the value for function t x function value. So minus minus plus I p divided by h cross. Okay, I p divided by h cross values. Okay. Now, so once again differentiating x. Okay, once again differentiating with respect to x. Okay, so dou square psi by dou x square is equal to e power minus I by h cross into et minus px into like this value minus, that's the value for minus values. So that is value for this case I square p square divided by h cross squares. So dou square psi by dou x square equal to e power minus I by h cross into et minus px. Okay, I square p square divided by h cross square. Okay, the same values with the same values. So that value is equal to I square p square divided by h cross square. The other differentiating values. Here my I square p square's values. Okay, so this answer is equal to psi. You understand? E power minus I by h cross into et minus px is equal to psi. You just consider psi and I square minus 1. So minus 1 then p square divided by h cross square. Okay, that is value for dou square psi by dou x square. Okay, now just form p square of psi. P square of psi is equal to what answer? Minus h cross square into dou square psi by dou x square. Just cross multiplications. Okay, now this equation number 3. So okay, now this equation number 3. Now differentiate equation number 2 again. So that means differentiate equation number 2 with respect to t. Okay. Differentiating equation 2 to t. So what answer? T differentiating. So that is value for answer dou psi by dou t equal to dou psi by dou t is equal to e power minus I by h cross into what answer? Et minus px. Okay, here that is value for is like it is a t function's value. So minus I e by h cross. Okay, only know that is whole value is equal to psi. Okay, so psi into e power psi into minus I e divided by h cross values. But this equation, these values for just form e power e of psi values. That's e of psi values. So substitute here and p square of psi value substitute here values. Like this is value for equation number 1. Now this form, this value is equal to psi also. So psi into minus I e by h plus. That is value for dou psi by dou t. Now just form E of psi value. E of psi is equal to, what is the answer? E of psi is equal to h cross by I minus I value. So that is value E of psi equal to minus h cross by I into dou psi by dou t. Okay, understand? So 1 by I, okay, first numerator, that is the minus I value, minus minus plus. So I h cross into dou psi by dou t, that is value for E of psi values. Now this equation number 4. It's okay. Now equation number 3 and 4, substitute equation number 1, like this equation number 1. Understand? Like this equation number 1. So equation number 3 and 4, substitute equation number 1. So what is the E of psi value? E of psi is equal to I h cross into dou psi by dou t equal to E of psi plus 1 by 2 m. Understand? Then p square of psi. The p square of psi equal to equation number 3. So minus, what answer? H cross square dou square psi by dou x square. Understand? So the answer is dou psi by dou t is equal to E of psi plus, that means minus values, minus, what answer? H cross square divided by 2m into dou square psi by dou x square. Understand? Like these equations is known as time dependent wave equations. Okay, like this equation number 5. Understand? Equations 5, expression for time dependent wave equation. It's okay. Now these equations for one dimensional equation, otherwise its value for separately for psi value separately. So 1 I h cross divided by dou psi by dou t into psi is equal to, so psi is, in this case psi is a common factor, so v minus h cross square divided by 2m into dou square psi by dou square by dou t square. This common factor is psi. It's okay, this psi is a common factor. Like this case value for energy operators, otherwise these values for Hamiltonian operators. Okay, like this value I h cross dou by dou t is equal to E, energy operator, otherwise v minus h cross square divided by 2m dou square psi by dou square by dou t square is equal to Hamiltonian operators. Okay. So that is time dependent wave equations. Next is time independent wave equations. So time independent wave equation rather than use of time dependent wave equation, because the wave functions value psi, the wave functions value psi is dependent for time dependent wave equations values. Okay, so this time independent wave equations is also used for time dependent wave equations. So that's why use this value for time dependent wave equations. So finally this value substituting your dou psi by dou t's value, other dou square psi by dou x square's value. Substitute here. Okay, finally answers for what are the time independent wave equations. Okay, so you know that for psi for wave functions we equal to, we know that e power minus I by h cross into et minus p of x. Okay, et minus p of x values, that is a wave function. So just to separate values for e power minus I e by h cross into e power, this a is also, take a is a constant, so e power minus minus plus, so I p divided by h cross into x. Okay, I p x cross into x values. So here these values are separately, like this is a x function, like this is a t function's values. Okay, this is x function's value, like this is a t function's value. Now this x function's value is called psi, so a psi e power minus I e by h cross. Okay, so that is a wave functions. Okay, now this is equation number 1. So now equation number 1, differentiating with respect to t. Differentiating equation 1 with respect to t. Okay, so dou psi by dou t is equal to, like this is value for t functions, understand, like this is value for t functions value, like this is value for x functions values, understand. So that is value for a psi e power minus I e, okay, t divided by h cross into, like the t functions, so minus I e by h cross. Okay, and I e by h cross values. So that is equation number 2. Okay, so now equation number 1 again. So differentiate equation number 1 with respect to x. Okay, like this is the x function. Okay, differentiating equations 1 respect to x. Okay, so dou psi by dou x is equal to, like this x function, already know that. Okay, e power minus I e t divided by h cross, like this x function value. So that is value for dou psi by dou x. Okay, dou psi by dou x values. Okay. So now again differentiating once, again differentiating x. Okay, once again differentiating again x. So dou square psi by dou x square. Dou square psi by dou x square equal to, it's also a into e power minus I e t by h cross into dou square psi by dou x square. Okay, dou square psi by dou x square as well. Like this equation number 3. Okay, now equation number 2, this is equation number 1 and 3. Okay, substituting equation number, okay, substituting the time dependent wave equations. Like this is a dou psi by dou t for the here, then dou psi square by dou x square here. Okay, so equation 2 and 3. Okay, substitute in equation, substitute in time dependent wave equations. Okay, time dependent wave equations. This is a time dependent wave equations. So I h cross into dou psi by dou t, like this is a dou psi by dou t. So a into psi e power minus I e t by h cross into minus I e by h cross values. Okay, then that is very equal to v psi. The psi value already know that the psi is equal to a into psi. Okay, a into psi e power minus I e by I e t by h cross. Okay. Then again minus, okay, h cross square by 2m into dou square psi by dou x square. Okay, dou square psi by dou x square value. So a into e power minus I e t divided by h cross into dou square psi by dou x square. Okay, here its value a into e power minus I et by h plus is a common values for here. Okay, so divide, okay, a into e power minus I et divided by h plus. Okay, both sides divided by this value. So this answer is I h cross into e power minus I to e power 12. So this value for minus I e divided by h cross. Okay, like this is I. Okay, into equal to v of psi minus h cross divided by 2m rho square psi by rho h square. Okay, rho square psi by rho h square is value. So like this value is for this value for h cross cancel. At the same time I minus I, that is value for minus I square. So minus I square is equal to plus 1. So that is value for e psi value. Okay, so we have psi minus h cross divided by h cross square divided by 2m into rho square psi by rho h square. So, okay, rho square psi by rho h square is value. So value is here. So e of psi minus v of psi equal to minus h cross square divided by 2m into rho square psi by rho h square. Okay, rho square psi by rho h square is value. So this value here is a common factor is e minus v of psi equal to, okay, minus h cross square divided by 2m into rho square psi by rho h square. Okay. So now change this side. So what the answer is? This answer is, so this answer rho square psi by rho h square, okay, plus this cross multiplications to 2m by h cross square into what answer? E minus v of psi, okay, into rho square psi by answer v of psi. Okay, that's a v of psi. Okay, is equal to 0. Understand? Like this equation is known for Schrodinger time, okay, time independent wave equation. In this case, there is no t values. Okay, time independent wave equations with final answers.